All right, so let's talk about how to find the solution set for a vector equation that has infinite solutions. That's LE4. So we have a vector equation. This also could be given as a system of equations or as an augmented matrix. And then they've given us the reduced to echelon form of that augmented matrix below. So we can see our reduced to echelon form. If we want to, there's actually the first thing let's talk about is if we're finding the solution set and we have this equation, there are 5 unknowns that we would be solving for, right? And we already see 5 unknowns, 4 equations that this would correspond to, because we have these column vectors of dimension 4. I don't know if dimension's the right word, but they're column vectors with 4 elements. They're all in R4. But this lets me know there's going to be infinite solutions before I even saw the reduced or echelon form of that augmented matrix. But I'm mentioning this because we should know that our solution has to be a vector with 5 elements. All right. We also know that if we're writing a solution set, we're probably going to need some curly Q brackets. We're going to need to define some stuff. So let's just go ahead and write that. Now, if you need to, you work through rewriting this augmented matrix as a system of equations. So we go, okay, x1 minus x4 minus x5 is equal to 1. x2 minus 3x4 plus 2x5 is equal to negative 1. And x3 plus x4 minus 2x5 is equal to negative 1. So we can see here, we have these 2 free variables that all 3 of my variables corresponding to those pivots in my reduced to echelon form matrix are depending on, right? That they could change based on. So we're going to go ahead and let's say x4 is equal to A and x5 is equal to B. Now here's one thing that we're already missing on a number of these for those students who have been struggling on LE4. We are not putting in the A and B for our 4th and 5th elements, right? Even though we just defined them here. Instead, we're jumping straight to like solving X1 and all these other pieces for what we need. But then we can go ahead and say, all right, let me come in here, place all those X4s with A's, and all those X5s with B's. I lost some numbers. I'll have to put those back. B, 2B, and 2B. All right, and then we just solve each of these equations out. So we'd have x1 is equal to 1 plus A plus B, 1 plus A plus B. x2 is equal to negative 1 plus 3A minus 2B, negative 1 plus 3A minus 2B. I should have gave myself way more space. I can move that over. Minus 2B, and x3 is equal to negative 1 minus A plus 2B. Negative 1 minus A plus 2B. All right, and then we do need to say that A and B can be any real numbers, and then we are done. We've found now that we can write this number of ways. At the time we learned LE4, we didn't have all of these, but we could go ahead and write this as 1, negative 1, 0, 0, plus A times 1, 3, negative 1, 1, 0, and plus B times 1, negative 2, 2, 0, 1 for any A and B within R. This is a cool fact. Actually, we haven't chatted about it since we did this, but after we hit EV7, the homogeneous system of equations, this would be our solution to the homogeneous system, and any particular solution to our original vector equation for anything that we could solve, we could just add all of the homogeneous solutions as well. It's a kind of neat thing that you could do. And then we could also rewrite this, now that we've done EV2 as spanning sets, as the span of, can we write it as a span? No, because we have that one vector we don't have linear combinations of. So this is the only 2 ways that we could go. We lose out on spanning sets, but we can use those other 2 in this particular situation.